All right, let's look at some representations of exponential functions. So here we're starting off with a graph, and we're trying to make a table and equation from the graph. So I gotta try to estimate some values based on my graph. So it looks like at -1, I can see a point here is -12. Okay, 0 is -4, and then 1 looks like about -3. So what I need to do here is I need to, like, the other values aren't clear. Like this looks like some kind of decimal thing. I'm not sure. And then the -2 is like way off the graph. So I can't really figure that out. So what I'm going to do is I'm going to do some estimation using the values I already have in my table, okay, to figure out how much it's changing by. Well, I know that from -4 to -12, okay, so I'm going to try to figure out what it did. So I'm going to work backwards. -4 divided by -12 is a positive 1/3. Okay? So that means I'm multiplying by 1/3 each time. Okay? So that for my equation, it's y equals -4 times 1/3 to the x. Why am I not adding any number on the end? Simply because the horizontal asymptote is clearly going to be 0 here because it's getting closer and closer to that x-axis. That means the y, that makes the horizontal asymptote 0, okay? And then we are going to identify the rest of the points. That means I need to keep plugging it in. So this is going to be -4. And 4/9, okay? So I plug -2 in there, that makes it -36 for a table, okay? So we're gonna keep this to the side here, all right? But that's how you look at a graph and try to make the table and the equation from the graph. This is also equivalent to this, okay? But I just wrote this to clearly show where the horizontal asymptote is. What if we were only given the table? Well, I can use these points to plot some points here. 1.33. -1 is 2. 0 is 3. 1 is 4.5. 2 is 6. 1, 2, 3, 4, 5, 6. 0.75. Okay, so I've got some points on my graph here. However, I don't feel like I have enough information to clearly just draw the rest of the line of the graph because we really need to figure out what the horizontal asymptote. The best way to figure that out is from the equation. So we're going to try to check what is it doing here each time. All right. So we're going to do some division. We're going to take 2 points. And we're going to divide backwards to figure out in order to figure out what it's multiplying by. We could divide backwards to figure out what it's actually multiplying by. So I do 4.5 divided by 3, okay, which is about 1.1, or rather 1.5 or 3/2. And I know that the y-intercept is 3. So the equation here looks like the best way to do it would be to test it for each point. So if I do, I know that 3/2 times 1.333 is really 1 1/3. I know that would give me 1.3, that times that would give me 2. Then 3/2 times 2 would give me 3. 3/2 times 3 would give me 4.5. So it matches up. So with that information, I can make my equation, which is f of x equals 3 times 3/2 to the x. There is no horizontal asymptote here because it matches the equation, which means that the horizontal asymptote is actually this right here. It's 0. So I can sketch my graph. It's really important you try to sketch the entire graph. Don't just go like this. That's not the graph of the function. We know based on the behavior of exponential functions, it's going to get closer and closer and closer to this line, but not cross it, and it's going to keep going up like that. Okay? So we went from a table to equation and graph. Now let's go from an equation. All right, in this case, what if we were given just the equation? Okay? And in order to make the table and the graph, we'd have to first plug values into the table, and we can use those values in the table to make the graph. So let's do it this way. I'm going to plug values from here into the equation to see what numbers I'll get out. So if I do this on my calculator, I can -2, plug it in, I get -3.875. Plug -1 in, I get -3.75. I plug in 0, I get 3.5 negative. I plug in 1, I get -3. Plug in 2, I get -2. So that means my graph's going to look kind of like this. So -2 is about -3.875. -1 is about -3.75. 0 is about -3.5. I'm a little bit too low. Okay. 1 is -3. 2 is -2. Okay. I also know that my horizontal asymptote is -4 because of this value here on my equation. So I can go ahead and draw that. The equation for my horizontal asymptote is y equals -4. All right, so I'm going to extend my line here to connect some dots. And I've drawn my function and created my table. We're going to use this information to really expand on the idea of exponential functions. Let's look at some key features of this exponential function. So looking at this graph here, exponential functions are either increasing or decreasing. In this case, the graph is going up, so it is increasing. It is not decreasing, but it increases forever. Okay, I could write that, or I could write this. Okay? Now, with exponential functions, okay, there's clearly no maximum on this exponential function because it's going to go up forever and ever and ever, okay? Now, for the minimum for the exponential function, it's going to keep getting closer and closer and closer and closer and closer and closer to -4. But there isn't an absolute minimum on this graph, okay? So you could say it's getting closer and closer to -3, but it'll never reach an exact point for a minimum. The domain for all exponential functions go from -infinity to positive infinity, which means that they go on forever. Now, the range for an exponential function depends on the horizontal asymptote. So in this case, it's going down and down and down, getting closer and closer to -4, but it will not reach it. That's why it's closed. It's not a bracket, it's parentheses. It's not included. It's not an included value, but it's going to keep going up and up and up forever. So we write it like this. Okay. The x-intercepts in this case, there is no way to really find the x-intercept exactly, but we can do some estimation. For the y-intercept, we know from plugging into our table that the y-intercept is definitely going to be 0, -3.5. As far as the x-intercept, it's going to be some form of a decimal value. It's 5.129. The end behavior here is trying to look at what is it doing when it goes to the right, what is it doing when it's going to the left. So as it goes to the left, as x goes to negative infinity, the graph is going closer and closer to negative 4. As the graph goes to the right, to positive infinity, the graph is going up and up and up and up all the way to infinity. So that's your key features of an exponential function.